Hey everybody, Savas Algebra 2 here. Lesson 3-6. Getting close to the end, number 6 here. And we have this big, long polynomial, and we're supposed to find the zeros and repeat them. This is sometimes they want you to type them more than once if they happen. So the first thing that I did on this problem is I already took the negative 2x to the 5th plus 7x to the 4th minus 58x cubed plus 77x squared plus 2x minus 26, and put that over in Desmos for you. So if we look over there in Desmos, here's what we see. And so what we know here is that from that first point right there, that's a negative 1/2. And then over here, we have a bump off from that 1, which means that 1 is a double root when it does that. So that gives us 3 of our zeros. We know we have 5, so the last 2 are probably complex. So we're going to divide these out of here. And then we'll see what's left after we do that. So let's take the 1 out. Bring down the leading term, multiply the 1 times that, the 1 out in front. And that's negative 2, add straight down, 1 times the 5. Negative 58 and 5 added straight down. 1 times that. Make sure I don't make a mistake here. I think that's 24. And then add these. 1 times the 24 is 24 added to the 2 is 26, and 1 times the 26. So there's a 0. That's one of my 1s that I just took out. So I took out 1 here. Now I got to go do a second one out of this step. So take that one out. What do we have? Take a 1 out of here. And we would have, bring down the negative 2. 1 times negative 2. Negative 2 add straight down. 1 times 3. Add straight down. 1 times a negative 50. Add straight down, and 1 times negative 26, adding, and so that confirms my 2 1s. Now the next one is a little tricky because it's this negative 1/2, and if we remember that x equals negative 1/2, you can't have fractions. So if you multiply both sides by 2, you'd have 2x equals negative 1, and add your factor for this is really 2x plus 1 equals 0. And so if you think about long division with this problem, 2x plus 1, I'm taking out that out of this problem over here, which is a negative 2x cubed plus 3x squared minus 50x minus 26. And so if you remember how to do the long division like we've done, I want to just, because something happens here that's usually a little bit unique. 2x times x squared, a negative x squared would give me my negative 2x cubed. And then I would have a negative x squared. But since I'm really subtracting here, this is going to be a plus on this one. So I'm going to have a 4x squared left, and still my minus 50x and my minus 26. And so after this, now I'm going to say 2x times a 2x to get my 4x squared. And then 2x times the positive 1 is another 2x. So now I've got subtracting, remember, this is like a negative. So I've got negative 52x. And so 2 times a 26 negative So then when I take that and multiply it back out, I would have the negative 52x, and negative 26 times 1 is a negative 26, and this was a negative 26. So what's left after I get done here, when I divide it, is this. But watch what happens if I go over here. I try to use this negative 1/2 as my other zeros. So you bring, let me redraw that line, see if I can get a little straighter. Negative 2 down, negative 2 times 1/2 is 1, add straight down 4. Negative 1/2 times 4, negative 2, add straight down negative 52. Negative 1/2 times a negative 52 is a 26, and add straight down. And so it shows my zero remainder, but look, compare these. This is what I'm trying to get at here. This is negative 52, that's a 4x, and this is an x squared. But if you look at that answer, we know the long division problem is right, because, but if you look over here, compare these two that I'm circling in yellow. What you have to do in this case, because you were dividing by the 1/2, and this 1/2 is like you're saying x equals negative 1/2, but really it was supposed to be 2x plus 1. So because we lost half of them, these are all, we were dividing by half as much as we should have. We were only dividing by 1x instead of 2x's. So all these have to be divided by 2 to actually get to your correct answer. So a negative x squared plus 2x and a minus 26 here to get what the correct answer was over in this situation. So then the last thing we still needed to do was, what are the zeros here? We still haven't found these. So we've got a negative x squared plus 2x minus 26. That's not going to factor. And, you know, maybe at some point here you get to a point where you're like, I'm going to go put it in Wolfram even, and just because I want to make sure I get it right after putting all this work into it. So let's check out our negative x squared plus 2x minus 26. Negative x squared plus 2x, yeah, that's it. And when you put it into Wolfram, I hit enter just to submit it. And you come down here and it finds your zeros of 1 minus 5i and 1 plus 5i. So we could have done that in the quadratic formula or whatever and gotten it all. But we had our 1, a 1, was it a positive half, negative half? And then from Wolfram, what did I say that was? 1 minus 5i and 1 plus 5i. Whew, what a problem. All right, so hopefully that gives you some of it, but then we still have the second part. Write it out in factored form. So use the complex zeros to factor. So, I mean, we would have had our x minus 1, our x minus 1. We already wrote out that it was 2x plus 1 when we change the negative 1/2 0 into the factored form. And then the x minus, let's write this out up here again, just to make sure I don't do all this work and then make a mistake. X minus 1 minus 5i and x minus 1 plus 5i. If you distribute those minuses, we're going to have x minus 1 in both of them, but then a minus 5i and a plus 5i. So x x minus 1 minus 5i and x minus 1 plus 5i. Whew. It says it doesn't like it. I don't know if they want these left. I don't think this would be it. The 1 minus 5i and the 1 plus 5i were right. X minus 1, 2x plus 1 is, double check that. When x equals, if x equals negative 1/2 multiplied by 2 would be 2x equals negative 1 and add 1 to the other side. So that's 2x plus 1 for that factor. The x minus 1, because it was a positive one that we took out twice. Yep. And that. And then the x minus 1 minus 5i and the x minus 1 plus 5i. Maybe it's all that underneath. Simple. Oh, we're supposed to simplify this? No. Simplify your answer. Type your answer in factored form. Expressed complex numbers in terms of I. And use the integers or fractions for any numbers in the expression. Well, final check, and then I'm just going to say, what were they looking for? If we can even see it. X minus 1 minus 5i, 1 plus 5i. Oh, they wanted the squared written as a squared. And we did need to have a -2 stretch factor out front. That's the thing that we did actually miss. Because the leading term up here had a -2, we should have had a -2 out here in front. Otherwise, we had all the rest of it. So if that's all it is, you guys can get that. I'm not going to go back and work another problem. All right, good luck.